Today we're going to be looking at our Learning Target 3 for Unit 5, which is I can informally use angles in triangles and parallel lines to establish facts about angle relationships. And we're going to focus mainly on the triangle facts today. So our first triangle fact is one that you've definitely used before, and it's called the angle sum of a triangle. And what the angle sum of a triangle states is the sum of the measures of the interior angles of a triangle is 180 degrees. So in basic terms, if you add up all three angles inside a triangle, they should equal 180 degrees, or they do equal 180 degrees. So if we're looking at our example here, we have angle X, angle Y, angle Z. So even though I do not know what those measurements actually are, I know for a fact that if I were to add all three of them together, they would equal 180 degrees. Our second triangle fact is called exterior angles of a triangle, or the exterior angle theorem. And this theorem, or this fact, states the measure of an exterior angle of a triangle is equal to the measures of its two opposite interior angles. So if we look at our example diagram here, our exterior angle is angle D. Notice it's outside of a triangle, and if we were to extend one leg of the triangle beyond one of the vertices of the triangle, we would see we get this outside angle. It's outside of the triangle. So if we were to take the two opposite interior angles, which are A and B, and if we took A plus B, the sum of those two angles is going to be equal to that exterior angle, that angle that's formed outside the triangle. Our third triangle fact is angle-angle similarity, and this states if two angles of one triangle are equal or congruent, to two angles of another triangle, then the triangles are similar. So if we look at our diagram, if A is congruent to F, which we can see that it is because of the single arcs, and angle B is congruent to G, which we can see that it is because of the double arcs, then based off of those two angles being congruent, we can say that triangle ABC is similar to triangle FGH. And the key with this fact is you only need two angles proven congruent. So let's try putting these to use. So our first couple of examples, we're going to be working with the angle sum of a triangle, which is that the sum of the measures of the interior angles of a triangle is 180 degrees. So letter A says, what is the third angle of a right triangle if one of the angle measures is 51 degrees? So sometimes I like to actually draw the triangle. So I notice in my description it says this is a right triangle. So I'm going to draw a right triangle, and it tells me that one of the angle measures is 51 degrees. For the sake of labeling our diagram, it does not matter which you label as 51 degrees, because regardless it will work out the same. So the key part about this is we have to remember that a right angle is 90 degrees. So to set up this problem, I would do 90 plus 51 plus my missing angle, we'll just call it x. And we know that the sum of the three angles in a triangle have to add up to 180 degrees. Okay, so if we add 90 plus 51, we get 141 plus x equals 180. And then we can go ahead and solve as we would any one-step equation. And we get that x is equal to 39 degrees. So our missing angle is equal to 39 degrees. Looking at example 2, it says in XYZ, we can assume it's a triangle, the measure of angle Z is equal to 113 degrees, and the measure of angle X is equal to 28 degrees. What is the measure of angle Y? And if you haven't noticed, every time I see this M in front of the angle, that means the measure of. We are not multiplying a variable times the angle. This M just represents the phrase measure of the angle that follows. So if I have my triangle, and again I can draw a picture if it helps, you don't have to, and I have an angle of 113, I have an angle of 28 degrees, and I am looking for that last angle. So I would take 113 degrees plus 28 degrees plus x degrees equals 180. So 113 plus 28, ironically, it's 141 plus x equals 180. And we already did this on our previous problem, but we go ahead and subtract 141 from both sides, and we get x equals 39 degrees. I did not plan that. That just kind of happened. All right. Our last example with the angle sum of a triangle is the ultimate algebra triangle problem. Do you notice we have one angle is marked as 2x, and the other two angles are marked as just a single x? Now, while this looks like a right triangle, we can never assume anything. You have to go through the math to either prove that it is a right triangle, or, it might be 89 degrees for that angle, or 91 degrees. We don't know unless we measure it, or we can mathematically prove it. So I'm going to set this problem up just as I did the other two problems. One of my angles is labeled x, so I would say x plus my second angle, which is also labeled x, plus my third angle, which is labeled 2x, is all going to be equal to 180 degrees. If I simplify, so combine like terms, that gives me 4x is equal to 180 degrees. And then go ahead and solve by dividing by 4, which leaves me with x equals 45 degrees. So with that, if I were to say, is this a right triangle, I could then do 2 times 45, which would then prove, yes, this is 90 degrees. And this would be a right triangle. If we move on to example 2, we have exterior angles of a triangle. And if you recall from our definitions, the exterior angle of a triangle, it says the measure of the exterior angle, or the angle that's outside of the triangle, is equal to the measure of its two opposite interior angles. So if I look back at my first example here, I see my exterior angle is x, my exterior angle, and my two opposite interior angles are 37 and 72. So I can go by my fact that 37 plus 72 is going to be equal to that exterior angle. And 37 plus 72 is 109. So my exterior angle is 109 degrees. Okay, now the problems are not always that simple or that basic. Sometimes we will have to find one of our interior angles. We'll be given the exterior angle, but we have to find one of those opposite interior angles. So to do that, you set up your equation the same. I know that the sum of my two interior angles, so the sum of my two interior angles is going to be equal to my exterior angle. And then I would solve like any one-step equation, subtract 33 from both sides, and I can see that x is going to be equal to 33 degrees. So my missing interior angle is 33 degrees. And our last couple of examples are going to be with angle-angle similarity, to where we have to prove or to verify that two triangles are similar, and we'll have to do that by looking at if they have at least two angles congruent. So determine whether the triangles are similar. If so, write a similarity statement. So I notice right away I have one angle that's labeled 62, and I have another angle in the second triangle that's labeled 62. So I can see that angle A is congruent to angle E. That's something that I can see right off the bat. I don't have to do much calculating. However, when I look at my other angles that I'm given, I notice that I have 48 and 70. Now I can't just assume that this is not similar because those are different, because what about that third angle? I don't know yet. Maybe that might match up. So I have to do a little extra work using our first triangle fact of the angle sum of a triangle. So if I'm looking in my first triangle, triangle EFG, I'm going to calculate what is that missing angle. I'm just going to label it X, knowing that all of the angles in the triangle have to add up to 180 degrees. So 62 plus 48 is 110, plus X equals 180. And if I subtract 110 from both sides, that gives me X is equal to 70 degrees. And at that point, I can be done doing work because I can see that angle G is going to be congruent to angle C. So angle C is congruent to angle G. Now obviously if I did the work, I would find also that B is congruent to angle F, but I do not need to do that because it's the angle-angle similarity. I only need two angles to be congruent. So to write my similarity statement, I just need to make sure that my corresponding angles are in the same location as I write out my statement. So I would say that triangle, we'll say ABC first. So triangle ABC is similar. So notice I'm using that squiggle to represent similar. And triangle ABC is similar to triangle. Well, we have to look at what angle corresponds with A. We already figured that out up here. So E is going to be my first letter. B is the second letter. B corresponds to F. And C is my third letter. C corresponds to G. So triangle ABC is similar to EFG. Now in letter B in this example, we're going to be using our angle-angle similarity to help us actually find a value or find a side length. So in our question it says, how high is the ramp when it is 2 feet from the building? So here we have a ramp that is being built up to a building, and the question is asking, how high, how tall is that ramp when it is 2 feet from the building? So I'm going to look, and I know that I can see that angle C is congruent to angle B, And angle A is actually in the two triangles. If you notice, there's a triangle here, and then there's another triangle here. Angle A is the same in both. So we would be able to say that angle A is congruent to angle A, and then angle B is congruent to angle C. So since that tells me that I have two similar triangles, I can then use what I know about similar triangles, which is that the sides are proportional, to help me solve for this missing side length. So my missing value is h. And if I'm looking at my two triangles, h corresponds to side CD, which is 2.5 feet. So my first ratio that I write is h to 2.5. And since my triangles are similar, I know that the side lengths have to be proportional, or they have to have the same proportion. So since h was in my small triangle, I now have to find the other leg of my small triangle, which is 2 feet from the building, and we know that from point A all the way to the building is 20 feet, and this is 2 feet back. So that's going to be 18 over 20, because 20 is that side length of the full triangle. And I'm going to try to speed through this so my battery doesn't kaput on me. So we're going to think back to 7th grade. How do I solve a proportion that's set up like this? I use cross multiplication. So 20 times h is 20h, and 2.5 times 18 is equal to 45. And then I would divide by 20 on both sides, and I would get that the height 2 feet from the building of my ramp is 2 1/4 feet. Okay. I want you to make note of any questions you have in the margins of your notes so that we can go over those when we talk about them tomorrow. All right, thank you.